So let's check now our second example. We have this beam here with two vertical forces of 1800 Newton and 900 Newton going vertical downward, and we have these two supports here, and we want to again draw the shear force diagram and bending moment diagram. We will start as always by drawing the free body diagram. Here it is, our beam. We have here vertical force of 1800 Newton and another vertical force of 900 Newton. We have here vertical reaction of YB, and we have here vertical reaction of YA. If we consider this to be B point and this is point A. Of course, there should be also at the pin support another horizontal reaction, but we will neglect this one because we can see already that there are no any horizontal forces, so we know that it will be zero anyway. We know that the summation of the moments at any point will equal to zero, so let's take summation of the moment at point A, which will equal to zero. And we will know now why did we choose the moment at point A specifically. We could have chosen sigma moment at any point, but if we choose, for example, at this point or at this point, we will have the vertical reaction at point B as unknown and the vertical reaction at point A as unknown, so we will have only one equation with two unknowns now. But if we took the sigma of the moment at point A, we will cancel the moment due to point A, so we will have only the moment due to B, so it will be easy to calculate it. And the same way if we took sigma of the moment at point B, but we just have to cancel one of the vertical reactions. So let's start calculating sigma of the moment here. We have 1800 multiplied by 0.65 plus the 900 multiplied by 1.65. This will equal to the vertical reaction at point B multiplied by 2. Solving this equation, we will get that YB, which is the vertical reaction, equals to 1327.5 Newton. Okay, so now we can start by our second equation, which is sigma Fy equals 0. So we know that YA plus YB, which is now we know it as 1327.5, both will equal to 1800 plus 900, which means that the YA will equal to 1372.5 Newton. Now we have all the forces, we can start to draw our graphs. We'll start by drawing our beam here. We have here the vertical force of 900, and we have here the vertical force of 1800. We have here vertical reaction of 1327.5, and we have here another vertical reaction of 1372.5. We will start drawing our shear force diagram and bending moment diagram. First, let's draw these vertical lines so we can follow the location of the forces. Starting from the point at the left here, we will start by the vertical reaction, which is 1372.5. It is going upward, so we will move upward. We will keep going horizontal till we reach this vertical force. Here, this value is 1372.5. 0.5, we will face this vertical force of 1800 going downward. So we will go down till we reach the negative sign. So it's 1372.5 minus 1800 will equal to 427.5. We will keep going again horizontal till we reach the other vertical force, which is 900. We will go further downward till we reach 1327.5. We will keep going here and we will face the vertical reaction, which is the same value. It has to be the same value to close the graph. We will reach to the 0. We have here the negative sign shear and we have here the positive sign shear. Let's check now our bending moment. We can start calculating the moment from here at this point. Let's calculate it from the right side. We can of course calculate it from the right side or from the left side, but from the right side we have less forces, so it will be less complicated. From the right side we have the vertical force of 1327.5 multiplied by this distance. We will reach 464.6 Newton meter. And from the left side we'll calculate the moment here. Again, it's the vertical reaction multiplied by the distance. We will reach 829.1 Newton meter also. And it is concentrated forces, so we will connect by straight lines, as we can see here. And of course the value of the moment is positive. We draw it in the positive side, of course, because if you look at the moment, it is going in this direction, which means it is causing compression at the upper side and tension at the lower side, and we agreed that this is a sign for the positive moment. So that's it for our second example. Thank you.